Greetings, my name is Shofa Malaka. I'm a student in education at University of South Africa. Today I'm reflecting on my grade 6 Natural Sciences and Technology lesson on the topic of matter and materials, state of matter. The lesson was guided by 3 specific objectives, deliberately structured to progress through Bloom's taxonomy to build deep conceptual understanding. First, learners were required to identify and describe the 3 states of matter, which are the solid, the liquid, and the gas. This aligns with the lower order remembering and understanding levels. Second, they had to explain how materials change state through processes such as melting, freezing, evaporation, and condensation, while understanding the role of temperature in these changes. This targets the analyzing level as they connect thermal energy to phase changes. Third, learners had to evaluate the importance of phase changes in everyday life and natural phenomena. This directly achieves the high-order evaluating level of Bloom's taxonomy, pushing learners to critically assess the real-world significance of the water cycle and industrial processes. Now, lesson phases and teacher-learner roles. Let us look at how the 3 phases of the lesson were implemented, highlighting the dynamic roles of both teacher and learners. In the introduction phase, my role was to stimulate prior knowledge and hook engagement. I did this by showing a brief YouTube video that visually introduced the microscopic view of particles. The learner's role here was active observation and verbal self-explanation. They weren't just passively watching, they were asked to discuss what they saw with a partner, establishing an active learning environment from the outset to satisfy our first objective. During the lesson development phase, the core instruction took place. My role shifted to a facilitator. I introduced a shared Padlet wall where I posted guiding questions regarding temperature and phase changes. The learners took on the role of active investigators. Working in small groups, they collaborated to explain how heating and cooling cause materials to change state, posting their observations and real-world examples directly onto the digital wall to satisfy our second and third objectives. Finally, in the conclusion phase, my role was to consolidate the lesson and assess understanding. The learners participated in a gamified Kahoot quiz based on a true or false question and answer. This phase was crucial for summarizing the core facts of the lesson and giving learners immediate, low-stakes feedback on their progress. Now, the ICT integration and SAMR model. The ICT integration and SAMR model justification. To enhance learning, 4 ICT tools were strategically integrated, spanning different levels of the SAMR model. First, the YouTube video in the introduction functioned at the substitution level. It substituted a traditional textbook diagram with a moving visual of particles, offering a functional enhancement through dynamic animation but keeping the core task the same. Second, the Microsoft Word document poster. It is a sheet that functioned at the augmentation level. Instead of a standard paper handout, learners utilized a digital docs file. This augmented the task because they could use a digital visual poster, spell check, and built-in dictionaries to support their science vocabulary development. Third, Padlet was integrated during the development phase, representing the modification level. Padlet significantly redesigned the traditional individual desk work task. It allowed for real-time, synchronous collaboration where learners could see their peers' ideas instantly, comment on them, and build a collective digital discussion explaining and evaluating phase changes. This level of collaborative learning is impossible with traditional pen and paper. Fourth, Kahoot was utilized in the conclusion. The tool sits at the augmentation level for assessment. It takes a traditional true or false quiz and enhances it through gamification, immediate automated data feedback for the teacher, and instant performance matrix for the learners, significantly increasing engagement. Inclusive teaching and differentiation. To ensure an inclusive learning environment, differentiation was woven into the ICT choices. For learners facing reading or language barriers, the YouTube video provided essential visual and auditory scaffolding to help them describe the state of matter. For kinesthetic and social learners, the interactive nature of Padlet and Kahoot kept them physically and mentally engaged. Furthermore, the Microsoft Word sheet. The poster I provided modified visions with center status visual pictures to accommodate diverse learning abilities, ensuring every grade 6 learner could access the content equitably. Now for the conclusion, critical reflection on effectiveness. Reflecting deeply on the lesson's effectiveness, the integration of collaborative ICT tools drastically improved learner engagement compared to traditional style of teaching. The learners truly grasped how temperature influences molecular movement. However, as a practical improvement for future teaching, I noticed that relying heavily on live tools like Padlet can cause minor delays if the school's internet connection fluctuates. If I were to teach this lesson again, I would implement a hybrid approach. I would have a physical whiteboard backup grid ready I'd have a physical whiteboard backup grid ready for phase change drawings, ensuring that technical hiccups never compromise valuable instructional time. Thank you for your time.